Right, so in section 7.2, we're going to continue thinking about some of the definitions that we saw in the last section. In the last section, we learned that statistics, again, statistics being results of samples in this case, are used to make estimations about populations. There are potentially sources of bias when collecting data from surveys. So in this section, we're going to explore the question, how can we judge whether our estimators are working? What separates a good estimation method from a bad one? Right, so to begin with at the top, evaluating surveys. Statisticians evaluate the method used for a survey, not the outcome for a single survey. Right, so we're not necessarily paying attention to the results, we're looking at the method that was used to collect these results. Is this method going to give us accurate predictions? If a group of researchers were to survey 1,000 randomly selected people, we would expect the results to vary from sample to sample. Because we would want to know how the group did as a whole, we're going to evaluate the estimation methods, not the actual individual estimates. And we're more worried about the process in this case. Right? An estimation method should be both accurate and precise. Accurate right? The method measures what it intended. It correctly estimates the population of the parameter. It is unbiased. So accurate means our estimations are correct. So that's one thing that we want our surveys to be. Then the other thing that we're going to look at is precision. Right? If the method is repeated, the estimates are very consistent. Right? So precision, actually I'm going to go ahead and change that just to the word precise. Right? It is going to be precise. Right? So if our estimate is precise, again, it's consistent. Right? There is very little variation. Okay, so at the bottom here we have 3 images. If the goal is to get the golf ball in the hole, which of these pictures shows a method that is accurate, precise, and both? All right, so if we look at the first one, our hole being the larger white circle in the middle of all of these. This one shows both accurate and precise. Right, it is accurate because the aim is close to the hole, and it is precise because there's very little variation, right? They aren't very spread out. This one we see a cluster that are kind of close together. So this one is going to show precision, right? Because they are close together or consistent. Right. However, move this up just a tiny bit. This does not show accuracy. Right? Accuracy means it's correct. In this case, it's not correct. The aim is a little to the right. So poor aim is an example of non-accurate results. So this last one, we're going to say shows accuracy because these are centered around the cup, but it does not show precision because these are very spread out. There is a lot of spread. Right, so accuracy, again, means that we have a correct estimate, right? Or in this case, good aim. And then precision means how far our data is spread out. Right? So again, the first example here shows both, and then these other 2 little images only show one of those 2 different characteristics.